Um, Hello, this is Archit Ghosh. Uh, this is second task 2 of data science and business analytics section. So in this task, we will try to predict minimum optimal number of clusters for our iris datasets, which is fairly common dataset. So we will check what are, we will first import our required libraries, and then we will import our dataset too. We see these are the attributes such as sepal length, sepal width, petal length, petal width. And now we will try to uh, cluster all of these together, and, and try to find out what is the minimum number of clusters uh, which could describe our database. So we could also go for something like DB scan or hierarchical clustering, where it is not required to exactly say that you need X or Y number of clusters. But in this case, we will be using k-means clusters. So for that reason, it is very much required to understand what will be the minimum number of clusters required. So uh, now I will be using Silhouette's code to determine that. Uh, so you can see here, like I've done the silhouette analysis for different amount of clusters. So this is for if there are 2 clusters for the dataset, if there is 3 clusters, if there are 4 clusters, and if there are 5 clusters. Um, I can, just by looking at this, I can just reject the 4 clusters or 5 clusters section, because you can see the average line of silhouette's code. There is uh, one area which is less than the average line, and same goes for here too. So I can just reject this too. Now coming back to choosing between cluster number 2 and cluster number 3, I will go for cluster number 3 because the areas are much more uniformly distributed among them. So I have decided that the optimal cluster for our dataset will be 3. At the same time, one can use elbow method to determine, and other methods to what will be the minimum number of clusters. Now, uh, now we will be using sklearn's building k-means uh, function for our cluster. So I've chosen there will be 3 clusters, and uh, for each, and there will be like 300 iteration at each time to determine both the centroid. Okay, and then I plotted I plotted for I plotted the clusters for the first 2 attributes of sepal width and sepal length. So you can see where is the centroid of my clusters, and how our clusters actually look. How my cluster actually look. Now I can also visualize according to the last 2 columns, which are petal width and petal length, and see how my clusters look. So you can see like for sepal length and sepal width, iris setos, I can completely segregate out iris vesicola, but iris setosa and iris virginica, and there is some amalgamation between them. And for other 2 attributes, iris vesicular is again separated completely, but there is some amalgamation among iris virginica and iris setosa. So thank you.